networking, the demand for efficiency and reliability has pushed the necessity of network automation. Network automation refers to the utilization of tools and scripts to streamline and simplify the configuration, management, and monitoring of network devices. The need for network automation in the industry comes from challenges associated with manual configuration processes. The task of manually configuring protocol such as OSPF, often shortened buffers on routers, proved to be time-consuming and prone to human errors. Thus, our group project addresses this issue by proposing a solution based on network automation approaches. The aim of this group project is to automate the process of configuring OSPF and backup configuration for routers, ensuring a more efficient network deployment. So, I will talk about the problem statements of this project. First, tedious manual configuration. Manually configuring routers individually is time-consuming and laborious, especially when dealing with numerous devices. Second, scalability challenges. The difficulty arises when setting up numerous routers, especially in large environments such as office building and university, leading to scalability challenges. Third, potential for errors. Manual configuration increases the risk of human errors, which can lead to network outages, security vulnerabilities, or performance issues.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Isani Yusri. My student ID is 2021486146. So I'm going to present to you about the project specification. First one is our project scope. This project will focus on how to configure the fundamental OSPF setup using Python and library. The next scope is the network environment will also be improved as part of this project to make configuration simpler. The last one is to improve operational and efficiency by reducing manual configuration errors and time-consuming repetitive tasks. We move to the project objective. We have three objectives. So the first one is to develop network automation using OSPF. The second objective is to automate network operations and configuration tasks in a GNS3 network simulation using OSPF communication. And the last objective is to automate the deployment of network services, protocols, and features. We're going to move to the project requirements. So we have two requirements, which is hardware and software requirements. So the first hardware requirements is the personal computer that we use to do the simulation. So we use the Asus VivoBook laptop. And for software requirements, we use GNS3 VM, VMware Workstation, and the Python as the programming language. The significance of our project, we have three. So the first one is minimize the possibility of human error and guarantees consistent network behavior, both of which are essential for debugging and troubleshooting. The next significance are aids in evaluating the network's capacity for resilience and situational adaptation. And the last one is to improve productivity, complies to contemporary network administration standards, and equips network specialists for the difficulties of practical networking situations. So now we go to the next slide, which is the network topology. So as you can see, this is our network topology. We have one cloud server, we use 3 routers and 3 ECS client and 1 switch. So each router R1, R2 and R3 will be configured with OSPF and DHCP. Each router also will automate backup process, and Cloud 1 will deploy a Python script. That's all for me. Thank you.
Assalamualaikum, my name is Siti Dariza and I will explain how our network automation works in this part. Our network automation comprises 2 main Python scripts and 1 YAML file. The first one is config.py script. This script is to automate the configuration of the router with OSPF and DHCP configuration. The second is backup.py script that to automate the process of backing up the running configuration. The last one is YML file, which is inventory.yml. This file contains all information about router like IP address, pool, network, gateway, and area of the configuration of router. Now I will explain in more details for each assignment of code in both Python script. In config.py, use NetMiko abilities to create SSH connection and carry out the command for device configuration. It to enable of OSPF and DHCP configuration of the router easily. This script will retrieve pool, network, and gateway address for DHCP configuration. The function netmiko_con enables the script to establish a netmiko connection for every router. The script can read the inventory.yml file by using the function yml. Next is backup.py script. This script is to operate the important task of automation backup process for running router configuration. It will collect the current configuration from routers by remote command execution and organize it into the text file. This script uses the backup function after looping through the each router IP address. By using the backup function, this script can connect to any router using NetMiko and execute the show running configuration config. Command like a config script, this script can read the inventory.yml file by using the function yml. The last one is inventory.yml file. This file is the information about every router in the network are stored in the inventory.yml file. The information is like interface IP address, pool network address, and gateway address and area of each router. It is contents of this file are to successful execution of the config.py and backup.py scripts. This file also provides the network topology as an organized, easily maintained source of the truth and enabling scalability and flexibility as the network evolves.
My name is Wan Aisharifatuna Bentiwan Aziz, and today I will present about a result and analysis. The network automation for this project consists of the two major Python script, as you can see in the method. This component can contribute greatly to the optimization and simplification of the network management task. The use of the Python script has resulted in a gain in network administration efficiency and effectiveness. Automation has speed up operation and reduced the possibility of human error, resulting in a more stable and dependable network infrastructure. The use of a Python script for the network setup and the backup, along with the structured data storage in the YAML format, has resulted in solid foundation for the network automation. Now, in this slide, we can see the configuration of the network devices which OSPF and DHCP was first automated using a micro library, enabling a seamless automation over the SSH. The show running configuration command will be executed under R1. Default setting will be reflected in the output since no configuration has been applied. First, we need to set up the SSH on each router 1, router 2, and router 3. None of the routers have been set up, as seen by the lack of any specified setting. Following that, we will go to the command prompt to begin running the Python script. The first script to run is a config.py, which is in charge of the automation, the OSPF and HCP configuration. Following the execution, the output will provide the information about the automation process. Each router is automatically configured using OSPF and DHCP demonstrate the success of the automation. The current configuration of the router will provide the automated setup have been implemented successfully. Next, the router are set up using a DHCP pool and all associated interfaces have IP address given to them. The show IP protocol command can be used to validate the OSPF setup which certifies successful OSPF configuration. This verification also applied to the ID router. Another technique of verification is to allocate IP address to PC via DHCP. DHCP will be assigned to DHCP will be used to assign an IP address. As we can see, the PC already an IP address assigned by DHCP. We will then move to another PC. As we can see, DHCP successfully allocated IP address to all the PC. To test our OSPF setting, we will try to pin from one PC to another PC. For example, in this slide, we try to pin from PC2 to PC3. The IP address of the PC3 is, as you can see in the slide, and we observe the pin is successful. In the next step, we will try to automate the backup process of the newly configured router using OSPF and DHCP. So we'll run the backup, which is backup py. In the command prompt, a script connects to each router to backup its configuration. In the backup folder created by the script, all the routers have successfully backup their configuration. This folder will contain a text file contain a router configuration detail. In the case of a script run on the different date, a new folder will be created with a date stamp. Ensure that the organization of a configuration backup. If a configuration loss or troubleshoot issue is happen, the backup file will provide a quick fix.
In conclusion, the influence of network automation extends far beyond user convenience, significantly streamlining the workflow for network architects. As technical complexity grows dramatically, the transition from manual configuration of router and switches to automation become a requirement rather than a luxury. This project has not only demonstrated the undeniable benefits of network automation, particularly in reducing burden of network architect, but it has also demonstrated its potential to transform network infrastructure management. By embracing automation, we pave the path for a more efficient, user-friendly, and future-proof network landscape where network architects can focus on strategic goals rather than repetitive tasks. As a result, this project shows the groundbreaking capabilities of automation as well as its potential to empower network architects and optimize network operation in the age of digital complexity.